Hi, everyone. Welcome to the Art of the Possible series. I'm Nihali Niyogi, and I am a principal cloud architect at Microsoft. Today's topic is security in AI Foundry Agent and the network perspective. With me, I have few of my amazing colleagues, Walter, Gabe, and Meera. I've truly enjoyed working with all of you and your collaboration and being available to bounce off ideas. We envision this series to be a multi-part series. The goal of the first session is to show the network plumbing, right, using a mock scenario. In part two, Walter will be showing us more realistic scenario with developer perspective. Walter has also built a fantastic workshop for the developers to learn. The founding principles of this session is to inspire collaboration between infra and dev teams and grow and learn together. With that, I will turn it over to first Gabe, then Walter and Meera to introduce themselves and perhaps tell us your vision for this series as well. Over to you, Gabe.
Hi, everyone. I'm Gabe. Nahali and I have worked on a few other series together, and we'll link those as well later. But I am a escalation engineer on the Azure AI support team. I focus mainly on, obviously, AI Foundry, Azure Machine Learning, and I have I'm an SME in the networking area for these resources. Walter?
Thanks a lot, Gabe. My name is Walter Novoa. I'm a cloud architect for Microsoft Americas, and I'm specialized in Azure App Innovation and generative AI services. I'm very happy to be here with this cross team in which we all are going to learn different perspectives to manage our Azure AI services. Thank you.
And
Meera.
I'll go next. Yeah. Hi, everyone. My name is Meera. So I'm on the product team for Azure AI Foundry. I'm specifically looking at enterprise-related features. So that would include networking, identity and RBAC, connections, and so forth. So yeah, here from the product side to just share a little bit more on maybe the larger goal with Foundry as a whole and where we're going. And then I'll hand it off to these awesome folks to do a demo for you. So yeah, maybe I'll just quickly chat about kind of the direction of the product. So if you think about our journey with like large language models as a whole, the initial focus was on building these chatbots, right, that could respond to questions and simulate conversation. But with the new direction of agents, we're now pushing the boundaries of what LLMs can do. It's agents that are not just reactive, but they're proactive in orchestrating workflows, making decisions, and driving real productivity gains across customer systems. And so with this evolution comes this like natural and necessary shift to shift in how we think about security, right? As agents interact with sensitive data and trigger actions across services, the question becomes how do we secure the underlying infrastructure, specifically those computes that are required behind the scenes, like in our agent services case. And this is where we'll be talking today about the new network secured environment for the agent service. Specifically, it's a concept called bringing your own virtual network or custom virtual networking, which allows customers to deploy their agent service within their own secure network boundaries, giving them full control over the traffic flows, how resources are isolated, and how compliance requirements are met. So this is what we're going to be talking about for this session. And this is also now possible with the general availability of the agent service that's supported in the new Foundry resource type, which I believe Gabe will share a little bit more about. And this is a big step forward in keeping our service secure, but also flexible for customers, and ensures that we are scaling the capabilities of agents while also scaling the trust and controls that our customers are expecting. So yeah, I'll hand it off to the rest of these guys to dive more into the details. But yeah, thanks, Natalie. Thanks, guys.
Excellent, Meera. Thank you so much for joining us. I know your time is valuable, and I know you have a conflict for the rest of the session, but really appreciate the PG perspective here. So thank you again. And again, welcome, Walter and Gabe. Appreciate your time. So I like to start at the official Azure documentation for the topic for today, which is securing AI Foundry Agent. So this is the official documentation link. We'll put it in the description below. And then there are a couple of good architecture diagrams for basic and standard agent setup. Gabe will be talking about this at depth later. And then finally, there is a GitHub repo which has some templates for the standard agent deployment that we will share later. So let me go to the Draw.io. So if you've been following along with us, this screen would look familiar to you. We use layers in the Draw.io to tell the story. Typically, we start with a hybrid cloud architecture. So there is a VNET in Azure, and then we show an on-prem, which is connected using ExpressRoute or some sort of private connectivity, and a classic hub spoke architecture where you have a spoke connected to hub. This is our starting point in all of our sessions. And prior to doing this session, we've done AI Foundry Hub networking and ML Studio networking. So there are different tabs over here in this diagram. We will be sharing all of these diagrams in the GitHub repo link below. And then I do want to call out the personas that you'll see three different, when we talk about flows and network flows, we'll have three different people, one sitting across the express route in the data center or some sort of private branch connectivity. This developer is sitting right on a VM in Azure, and this red user being external, right? So these are the three personas that we will be using to show the different flows. With that, I will start with today's topic, which is AI Foundry and particularly agent networking and security. We also typically have an existing customer PaaS environment, and with this as a starting point, we would add Foundry. So there we have the Azure AI Foundry over here. And I want to call out a difference that you will see. Gabe's going to go into the details on this one. But you will see that in the portal, there is AI Hub and then there is AI Foundry. Today's topic, we will be focusing on AI Foundry right here. Our previous sessions covered AI Hub. With that, Gabe, I'll turn it over to you and I will bring up our portal. So we will be deploying AI Foundry. And over to you, Gabe, ground us with some of the new terminology and talk us through it.
Thanks, Nihali. So as you can see on Nihali's screen here, there are two types of AI Foundries, right? So AI Foundry in general is still the PaaS service offering for enterprise AI operations, model builders, app development, etc. We did split this into two. The AI hubs that you see on your screen is the older architecture that you saw in the previous videos. This still uses AI Foundry projects. You have a hub and you create projects underneath that hub. For AI hubs, the resource provider we use is the Azure Machine Learning Service, while for AI Foundry, this would fall under the Cognitive Services resource provider. Okay. In general, we recommend using AI Foundry, especially if you're going to build agents or work with models. Our GA service for agents is in AI Foundry, while hub-based projects only has previews. If there are any features specific things like open source models, like Hugging Face, you'd probably want to use AI hubs. But in this scenario, since we're working with agents, we're going to be using AI Foundry. I'm going to share a link here that, Ali, if you want to open, it kind of goes over the difference between the two types of Foundry projects and which use cases would work best for you. Okay.
Sure. Yeah. Let me open it here.
Yeah, and you can see here if you're looking for agents, most of the features you'd want to be using Foundry projects, but if there is anything specific to hubs that you want to use, please refer to this table. Okay. That would be the main thing. Notice that with new Foundry, since it's under Cognitive Services RP, we no longer have the additional dependencies on Azure Storage, Key Vault, etc. Right? So that is another main appeal for this. Okay. That should be the main differences between the two. So we can get started with creating one.
Excellent. Yeah. So what we will do is, like Gabe mentioned, we'll create a new Foundry, and while that is being deployed, we'll come back here and do a lot more flows and talk through the architecture. So let's go back in here and we can create a new Foundry.
Perfect.
So cut it here. Foundry. We'll call this public, Gabe. Public resource group.
Yeah, that sounds great.
And we'll call this public for the name. And
Perfect.
we'll call this next.
Perfect.
Our favorite tab.
Over here, notice that we have our regular settings for inbound access to the AI Foundry resource, right? The first one would be all networks, meaning anyone from anywhere on the internet can access this. For selected networks, you can add your own IP allow list. You can also create service endpoints to allow access from specific subnets to this resource. Okay. And the most secure is disabled, where no public access is allowed at all, and you'd have to access this resource via the private endpoints. Okay. Notice that for AI Foundry, unlike hubs, there's no concept of a managed VNet here, right? That was a concept for hubs where your compute resources would get secured using the managed virtual network. In this case, we do not have that. So all of the resources would be secured with BYO VNet.
Perfect. And we'll select all networks for the public networking. And then later we'll deploy the secured one, right?
Mm-hmm.
Right. So ready to go to the next tab. So here I noticed that it automatically grants this AI user access to the project, right?
Mm-hmm. It's perfect. You'll see here there are two types: system assigned, user assigned. Makes sense. System assigned, we create that identity for you, while user assigned, you would provide your own identity. Note that if you are planning on using CMK, so customer managed keys, and bringing your own encryption, we do not have support for the user assigned identity together with CMK. So if you're planning to use provide your own encryption, please do use system assigned identities.
Perfect. So go to next.
Here we'll keep this as using MMK, which is Microsoft Managed Case. Don't need to add any tags, and we should be able to create it.
Awesome. All right, so we'll go ahead and hit create here. And while it is creating it, let's jump back into Draw.io. And so what we just did was we kicked off the build out of this AI Foundry. And let's walk through some of the flows, what we expect the architecture to look like. So you could always put a VM in the same in the hub VNet. You can create a subnet. In my case, in my demo, you would see that I have created a spoke VNet, peered it. I have a VNet peering with the hub, and a lot of the work I would be doing sitting on this VM right here. Okay, and I have a mock API running on another VM, which I will show you in a little bit. Then we have, so what happens with public networking, and if we look at the flows, is that this external user will have access to all of the resources, public access to all of these resources, including the customer's PaaS, AI Foundry. If you remember, we enabled it from all networks, and this mock API that is sitting on a VM. This mock API just simulates a real API. We also have public access to that mock API. Okay. So first thing that we will do is once the deployment is complete, we will log in to the Foundry. In this case, this external user can access Foundry, and this developer sitting internally or on-prem here, they all will access it through public access. Anything you would like to add, Gabe, on these two flows, the green and the blue?
No, I think that is good. All right, note that our user is accessing Foundry directly. There are no network, no NSGs, nothing, no firewalls, nothing blocking this access. So we should be able to freely access the resource from a network perspective. Yeah.
Perfect. Let's go see if our deployment is still running. Looks like it's complete. So what we will do is we will attempt this flow right here. So we will first review the public networking, like Gabe said, and then we will try this flow right here. I'm sitting outside, and we will try to open up the AI Foundry. So let's look at both the flows. So if we go to the resource, so in fact, let me go navigate it this way. The Foundry that we just installed does show up under AI Foundry. And Gabe, you want to talk just a little bit about the kind? I think there's a differences between Hub and this one, right?
So this would be where you can see a little bit of the differences, right? So if you were to click on the AI Foundry Public here, and under Resource Management, you can go to Properties. So if you see the resource ID here, under Providers, we are using Microsoft Cognitive Services, right? This is the RP for the AI Foundry resource, right? The AI Foundry based projects. For the AI Hub based projects, you would see Microsoft Machine Learning Services. Okay, so that would be one difference you'd see. If we go to the AI Foundry portal, you are also able to differentiate between a hub-based project versus an AI Foundry project. For hub-based projects, you'd see AI Hub, while if you click on the top right on the drop-down, yep, okay, and click on the working in, and you see here, it says AI services, which means it is a project, AI Foundry based project, okay? Not an AI Hub based project.
Great
Okay.
call out. Yeah, thanks. And this is good that we are seeing the errors in the demo, and we will use this time to work together and fix it as well, right? So Gabe, this is the AI user role permission. Should
Right.
we check before and after?
Yeah, let's just validate if it's there.
Sure.
But if you just click the Fix Me button, it should take care of it as well. So looks like it's already there.
It's already
So
there.
you should be able to ignore
Just
this.
ignore
But,
this?
yeah.
Okay. Okay.
Or you
Perfect.
can click Fix Me. Either way,
Okay.
the role is there, right? So
Okay, perfect.
should be okay.
Yeah, so here we, just to kind of recap what we did is we were able to publicly launch this AI Foundry portal. And that's the blue flow that we were seeing in the diagram, which is this user launching AI Foundry, and it works publicly. And let's take a quick look at one of the services that we would be using, which would be AI search. And AI search is public, and you can see that there is, when it's public, there is no networking tab, if I'm not mistaken, right, Gabe? If it's private, we get to see, if it's private, I get to see the networking tab. And with public, I think it's the SKU that decides for the search. Sorry, going back here for the public search. It's the tier, so it's the free tier, so it only supports public networking. So for me, this is in my setup here, this is all the customer PaaS services, and then we have the function app. So let me show you the function app as well. So this, we'll just bring it here. And if we go to the function app here under networking, it says enabled with no restrictions. That means everything's reachable publicly. So with that, let me give you a quick overview of, well, before we can do anything in the playground, we would have to create a model, right? So because this is a brand new deployment, we start at the model deployment, right?
Perfect. Yep. Yeah, we can use this to deploy any model we want from the available catalog. I think for our purposes, we can keep it simple. We can use some GPT.
I believe I was using this one.
Perfect. Yeah. So we should be able to use this deployment for any of the agents we decide to use. Awesome.
Perfect. Anything you want to call out before anything in the management center before we go ahead and create an agent?
We can go over if you
Connected
want to look.
resources, at the connected resources, there's nothing
Notice
yet.
that we won't have anything here. If we are to add any knowledge sources or any additional tools we want to use, you'll see that connections will get created for those. Okay. We'll go over it on our private scenario as well, because those we will see some additional connections here. But in the case of public, we are pretty simple flow, a basic agent, if you will.
Yeah, so let's go ahead and create our new agent. We're going to call our new agent Network Assistant 2.0. And just wanted to go over a couple of sections on this screen. I want to talk just a little bit about instructions. Instructions is where you define sort of the goals and behavior and the scope of the agent. We will be adding a knowledge source as well. So Gabe, this is very similar to bring your own sort of data sources like search index and the RAG scenario.
Absolutely. You'll see that for an agent, there is 3 main components, right? You have your LLM, which is what we deployed first to GPT-4o. That's what we'll be using for reasoning and language understanding. The instructions, as Nahali called out, is how you define the agent's goals, what it's supposed to do, what constraints it has. That's how you would use the instructions. And then you have tools. Tools would be your knowledge sources, your actions, your connected agents even, right? Those are the 3 main components of an agent. So for knowledge, if we add AI search, for example, as a knowledge source, it would be similar to what we showed in the bring your own data scenario, right? But those would be the 3 main components you'd have for an agent and building those agents.
And we could also add actions where we could integrate it with third-party APIs, which we will demo, right?
Yes, and actions would still be part of the tools that fall. But it would be part of the tool component for the agent, right? Basically, you can integrate it with any other code base you'd want. So.
Perfect. So let's go ahead and finish this creation of this agent. Okay, so let's start creating this agent. We'll add some instructions. So I'll paste the instructions over here. We are saying that you are an expert in Azure networking. You answer questions, networking questions. You're funny and you're from Boston. Okay, so that's all. So far, that's all we have given it. So let's see how this works. And then next we'll add knowledge and action. So let's try this in the playground. So we could ask something like, help me with point to site VPN in Azure. And it will help us. And we will say help. What is the capital of Texas? Oops, I have to send it. So I asked it to be funny. So it says, ha, that's a geographic question, not an Azure networking one. I am your networking pal. So you could see that it is only answering networking question. So let's add the knowledge here. So to add the knowledge, like Gabe mentioned over here, we will be adding this AI search But before I add it, let's just double check the settings on the search. So this is we will be using the public search, and let's take a quick look at the indexes. And we'll be using this index, and we'll just search for firewall. So just so you know, the way this search index was created was we uploaded a sample file. So let me show you the sample file in my storage account.
Yeah.
Let me go to the storage account where I have the original file that I used to create the index. So I have this file called Azure Networking Preview. If you look at the content, it just basically lists the free preview features for different services. And that's how the index was created. Okay, so I said firewall, and then it is listing the preview feature for private link for Azure Firewall. Okay, so we should make sure that it's working. The index does indeed work before we integrate it. So let's go ahead and integrate the AI search. So Gabe, I'll let you walk me through this one.
So here, since we did not have any connections or indexes, right, we won't find any indexes on this page. So what we'll need to do is add an index that is not part of this project. Here, if you click on the dropdown, you won't see any connected resources, right? We saw in the management center that we didn't have any connections. So we're going to have to add a connection to that public Azure AI search resource. So if you can click on this button, Nahali, you'll see that there is the top one, which is the private search. That's not the one we are interested in. So we're going to scroll down and go to the public, and we just click on add connections. It is using API keys to authenticate to it. Okay. Perfect. Now we can select the index that we want to use from that search connection. It's a little bit higher up. Yeah, here you see there are some already created. Otherwise, you see there is a create a new index button. If you don't have any, you can click on this and it would take you to search to create your own index. Okay, in this case, we already have an index, so we're going to use it. For display name, you can add anything. This is for future usage. If you want to connect this same index to different agents, they would show up under indexes that are already in this project with this particular name. And the search type, this particular index only has simple. If you have a more complex index, you'll see other options under search type.
Yeah, so I think in this one, I do have the hybrid and vector. Maybe we should use that one. Okay.
But for us, we are using the network preview, right? We want to make sure we use the...
Oh, yeah, you're right.
Yeah.
That's the one we tested. Yeah. Yeah, I think we should use that.
Yes, perfect. Okay, so here we'll connect, and that should add knowledge source to this index. And there it is.
Perfect. So now if we say list firewall preview features, it is indeed calling. Briefly, probably saw that it was calling.
Yep. And if you click on the thread logs, we should be able to also see.
Okay. Is the thread log same as view run info, or it gives more information?
You can use either. Run is going to be under the specific run, which called the search index. The thread, as you can see, has multiple runs, which is each time you made a call to the agent. Notice that on the previous one, it just used the LLM plus your instructions. In this scenario, since we were trying to fetch specific information that is under search, it will make a tool call to fetch the information from your index.
Yeah, so this is a tool call, and then the AI search, which is AI search public.
Mm-hmm.
Perfect. Yeah, so just kind of jumping back to the architecture, just showing what just happened is here we did so kind of the next level of flow where we had the AI Foundry agent deployed, and then flow from agent to the AI search happened publicly. So this pink flow is the one that we just demoed. Okay. And next we are going to show you how the agent can connect. We can add an action and we will connect to a mock API. So the next flow we're going to show you is this orange flow. So kind of jumping back to the portal. Sorry. Here. Are we ready to add the action, Gabe, or is there anything?
No, I think we're ready.
Okay, so before we add the action, because we're going to add an I have a mock API set up, so let's just jump on the VM, and I want to show you that the mock API first works locally, publicly, and then we will hit it through the Foundry portal. It's always best to just make sure that it works locally before we try to integrate with AI Foundry. So kind of control, I'll just clear the screen here. So here I have a mock API. I am on a VM in Azure right here. So kind of jumping just to get everyone oriented. I am logged into this VM, which is paired with the hub VNet. And I'm logged in right here. And I have a mock API. In fact, I take it back. I'm logged into this mock API VM, which is where I have an API running. Sorry. Okay, so here I am. So what we'll do is I have a very simple API that we will run on port 8000. And here on the same VM, I am using ngrok so that I'm forwarding. I get an HTTPS URL. Foundry requires an HTTPS endpoint, API endpoint, which is forwarding it to the local host port 8000. Okay, so first, so this is also on this bottom window. I'm also logged into that same VM. So let's first test it locally. So when we test it locally, we know that it is working. And on this right-hand window, I am on my machine, on my laptop. So we'll test it publicly using the ngrok URL. Let's just make sure that ngrok URL is still the same, 1828. So it should work. And there. So we made sure it works locally, it works publicly, and now let's integrate it with Foundry Agent. So here we will call it open. We will call it, and just one more note on this API endpoint. Basically, what it does is, if you see the call, if I give it subscription, if I give it a subscription name ABC, it just lists a few VNet in that subscription. Okay, that it's a simple API. You could, in fact, integrate it with Azure API as well to get the real VNet information. So going back here, so we'll go back. So we call this, so again, I was in actions, add, open API spec. We'll call this mock API VM. So it's running on a VM. And here we want to give it a description. So this tool will return VNETs in his subscription. So we say next. And here I have the schema created for OpenAPI schema. I created it using ChatGPT. So let me add those over here. It took me a few iterations to get this working right. I think the majority of the specs, I even fed this link to ChatGPT for it to do the right thing. So if you have an issue, just ensure that it is indeed HTTPS. You will not be able to talk to it using IP address or without any certificates. Anything else you want to call out on this schema, Walter, Gabe?
I think that's good. We will probably go over it a little bit more on part 2 when we work with Walter's code.
Sure.
Yeah, and this schema is very important when we are talking with the agent, trying to make it understand what are going to be the tools available for it to work. So it's very important to be very verbose and clear in the description that we add for the different paths or um, methods that are going to be available. Um, it should be like making prompt engineering here, giving the most possible amount of instructions for the agent. So with this, the agent will be able to detect what would be the intention of the users and then come here and choose the best tools to solve those intentions of the user. So very important to have a good open API schema here. And for example, in what we are going to see in our next session, we're going to learn how to get a good open API schema, for example, from our Azure functions when we have functionality there for our agents.
Yes, excellent. Thank you, Walter. Yeah, and like Walter mentioned, this description is also important so that it will do the right thing. For now, we will click through this and we will create this tool. So now we have a mock API that is integrated. Again, the idea is to see that it does indeed call this API. So if we say list VNets in subscription XYZ, and we do a demo. We are getting a 404. So let's troubleshoot. I want to make sure that my ngrok URL didn't change. It did indeed change since the last time I copied it. So this is a good. This is good that we are seeing this error. So this is what we need to fix. So this is where I think we may have to fix this description, return, or maybe we call it list VNets in a subscription. I know we had to refine this, Walter, a little bit to get it all right.
No.
List VNets in subscription in sub ABC. Yeah, so now it's calling it. So this description is important for it to know. Let's try more. List VNets in subscription XYZ. Yeah, you could see that it's making that OpenAI call, and let's double check. So we hit view run info, and here you can see under tool calls OpenAI, it is calling that mock.
Just a quick
Yep.
mention, it's Open API, not Open AI.
Sorry, Open API. Yep, Open API. Sorry.
No worries.
So I don't know why we have an X over here. This may have been the
This
old.
was the failure when you received the 404.
Okay. Okay, so
Right,
it's
when
showing.
the URL was incorrect.
Yes.
That call failed because it can't find that URL. So you'll see any failed calls from like the agent itself failing to call something versus if your function is failing to provide something, right?
Yeah. Got it. And it does list at the bottom, so I was clicking on that one. Okay, perfect. So it does list our VNets, and it's indeed calling that mock API. Okay, so now jumping back into the diagram, we just tested this flow. And last but not the least, we would connect our agent to an Azure function. Okay, so let's go back to the function. So we'll go into the Azure portal. I'll show you the function first. Make sure that it is available. It has public networking enabled, and my function is really very simple. It has two functions, a network agent and a ping agent. So before we test it from AI Foundry, let's just test it manually. So my function is very simple. We'll just test it here. First, we'll test the network agent function. Or let's test the ping agent. Basically, when I call the ping agent, again, this is a function URL, demo function URL. With the ping agent, if I call it, it is supposed to return Pong. And if I call it the network agent, let me just make sure my seed looks right here. Not sure if something happened. Okay, so and if I call my network agent, what I have that function, what that function does is it returns the HTTP headers. So when we call this function, we get to see all of the headers. This becomes more important when we are doing private networking, but that's basically what these two functions are doing. It's more for demo purposes, and we will be showing this flow right here through the Foundry portal. So let's jump back in and let's call this function. So we'll go and hit add. Since we don't have integration here through the portal, we are using the Open API tool. Oops, this is something. Let me just make sure. Picks up the existing one. Let me try it from here. So I go to the agent. I have the network assistant agent, and let's do an add over here. Okay, good. So we'll call it the ping agent, or so we can call it the ping action rather. And when the user says ping, you return pong. You return pong. I can't remember. Is this the accurate description, Walter, or did we have to add anything? But we'll see. So.
Well, have you defined the command per se?
Yeah, so it says it's a ping agent returns pong, and this is the function. It calls this function and returns that. The tool, let's see. And
What
we can
about the
just,
prompt?
I'm sorry?
What
The
about the
prompt.
prompt? Have you instructed your agent to receive this kind of commands? For example, ping.
Yeah, so it says
Oh
when
yeah,
you
you
receive
have it.
commands like ping, trigger appropriate action,
Yeah,
right?
that should work.
Yeah, and then let's add the API. Let's add another action while we are here. We call it HTTP header action. Return HTTP headers for the API call. Next, and I will put the and if you want to see the code, I will put that in the GitHub repo as well for these functions. Okay, and again, these are mostly created just to demo the connectivity aspects of it, kind of glean into the network flows. So let's go and test this in the playground. So we'll try this in the playground, and we say ping, and it's calling open API. We saw it briefly, and it returned Pong here. And if we do view run info, and it indeed called the ping action. And if I say view HTTP, give me HTTP head. It's again calling open API, and we can see that it is giving us all of the headers, and give me all headers. We'll give you all of the headers. You could see the user agent, Azure agents as the user agent. That I thought was interesting. The X forwarded for header. And when it's private networking, these become even more interesting. Anything you want to call out, guys, in the actions part?
Well, I think that was a great demo, Holly. Thanks.
Awesome. Yeah, so I think that we got all of these flows working. We first tested with the mock API. This could be any external API. Then we also got the pink flow, which is the search and knowledge. And then we talked to the agent. And so let's do the last part, which is a connected agent. So oops, I'm going to keep the agent here. Let's do a demo with a connected agent. So what we will do is we will create another agent, which will called so we will create a new agent called a check help. and it will call this existing network assistant 2.0 agent. So jumping back into the portal, we'll go to agents, new agent, and we'll call this check health. And let me give it some instructions. So these instructions are very important. Walter and I had to tweak this quite a bit to get this working properly. But basically what it says is that, oops, I have it twice for some reason. Sorry about that. So basically what it says is that when user says health check or check system, you will be perform the actions using the network assistant agent. Okay, so what we have to do here is we will use this feature called connected agent. We will add and we will connect this existing agent, and we will say network assistant agent connection. And steps to activate this agent is here. We say when the user says health check or a system check. Yeah, so then what it will do is it will call this agent 3 times. So you think I have some instruction twice. It will call the agent, the connected agent, first with pings, second time with headers, and then the third time with list VNets in subscription X, Y, and Z. And that will call this agent, the connected agent, 3 times and give us the final input. This is again just to demo a connected agent. Did you want to add anything else, Walter?
Yeah, in Azure AI Foundry, these connected agents offer a native and very deeply integrated mechanism for agent-to-agent collaboration within the same runtime environment. So unlike MCP or A2A, which are open protocols designed for communication across platforms or external services, these connected agents operate entirely within the Foundry orchestration layer. You know? So when the main agent emits a function call to a connected agent, the handoff is managed internally by the platform using standardized API calls over HTTPS, GraphQL, or gRPC. You know? So in the end, this internal invocation includes full thread context. It happens securely over Azure's backbone and requires no additional configuration or infrastructure. So this is an efficient and low latency approach for tightly coupled multi-agent workflows within a single solution stack.
Awesome. Thanks, Walter. Yeah, so just to kind of recap visually, this is the communication between agent to agent that Walter was mentioning and how that happens. So let's test it out. So we'll go and test this agent in the playground, and we'll say check health. And you can see it says connected, looking for references to connected agents. And then it's calling our network assistant agent. Ooh, we pulled it off at first try, guys.
Well done.
Very
Yeah, so
nice.
ping pong, it did. It also did the headers, and it also called that mock API. And it says everything seems to be operational and healthy. So this, if I light up all the layers, and again, we did this all for public networking. As you could see, all of the flows, and this is the full spectrum of flows. So again, the goal of these sessions are in the part one, we want to provide more networking eyes. And then in the second part, we will have a developer view, a very complex code view, and how we can stitch it all together. Okay, so this is again public networking. I have one last layer. In public networking, as you saw, DNS was not as big of an issue because all of the DNS, public DNS, is Azure by is done by the PaaS services. So we didn't have to do any private DNS zone. So you could see that my search public properly resolves to public IP, function resolves to public, and Foundry resolves to a public IP. DNS becomes more important in private networking, and we'll look at it more closely there. And same goes with the certificate. You know, because we were using the mock API with ngrok, the HTTPS was possible with a valid certificate because Foundry does need a trusted certificate to work. So I'll pause here. Any questions? Anything I missed covering in this? Gabe, Walter, yeah.
I think that looks good. Yeah, you called out everything.
Walter, any other thoughts?
I think we have covered everything.
Perfect. Yeah. So again, this was a very sort of demo, which was more for concepts and connections, a more realistic sort of network orchestrator and connections would look, if you had connected agents, would look something like this. I've just kind of put together a little visual just for a more realistic, useful network agents that can be used by an enterprise IT team. So that's the end of our demo. Gabe, anything you want to show? Anything I missed?
Perhaps we can go back to the management center and see any new connections that were created.
Oh,
If
good
you
point. I see. Yes, good point.
if you see here, we now have that AI search connection created, right? Notice that for any of the open API ones, we don't have a connection since this since it's not a built-in to Foundry, but rather a call using the Open API spec. But you see here, the search connection was created for that index we had earlier.
Awesome. Great call out. Thanks, Gabe. So with that, let's move on to the private networking. Let me hide all of the other layers here. Okay, so Private networking does get a little bit more involved because of the private endpoints and the dependencies with DNS, but we will walk you through all of the private endpoints. So with that, let me just show real quick the official documentation. And we'll jump right in the portal. Gabe, I'll have you walk through some terminology and the official documentation and the best way to kind of deploy private networking. Okay,
Sounds
so
good.
let me jump back to the portal. And I believe this is our official documentation for the architecture. And this is the script that deploys it. So I'll let you start over here.
Awesome. So as you can see in the documentation, right under the architecture diagram, you already see there are a few additional resources created for the setup. You may be wondering why is that the case? Previously, we didn't have any of those Surge, Storage, and Cosmos resources for your agent. Well, in this scenario, we have to use a standard agent to connect privately, okay? There are two types of agents. You have a basic agent and you have a standard agent. For the basic agent is what we did in public. All of the resources like storage, search, Cosmos are handled internally, okay? For a standard agent, that means you are providing your own resources for vector stores, for thread storage, and basically you'd be managing all that data instead of having those resources created on Microsoft's backend. Okay. You can see here that for private networking, we have to create those resources in a standard agent. Otherwise, this will not work. Okay. So when you have the agent VNet injected, that means we will have to use a standard agent, meaning you have to provide your own resources. Okay, that is the first part. Now, another thing, we notice there is an agent client subnet for your own virtual network. What happens is we are using VNet injection to add the container in which the agents are running into the client subnet. Okay, the subnet needs to be delegated. Otherwise, you'll run into problems creating this. Okay. One thing to note is we don't have any ways of doing this via the UI at this moment. So we have a bicep template to create this standard agent with private networking. Same thing, we have this in Terraform as well, if you prefer to work it using Terraform. But for this demo, we'll use the bicep template. Okay. That's where things start basically, right? The biggest difference that we want to start with is instead of using basic agents, we're going to use standard agents. So when I was mentioning you'd see additional connections on the Foundry resources, on the Foundry resource, I was referring to these connections to Cosmos, storage account, and search resource for your standard agent. Okay. Anything you'd like to add on this, Holly?
Yeah, so it's supported with both bring your own VNet as well as net new setup, right? So we're going to show both on bring your own VNet. So this VNet could be a existing one or it could be a net new one.
Right.
Okay, and just so I have the terminology right, when you say basic, when you say standard, these storage and the extra resources would have to be created manually. the storage, search, and Cosmos DB,
Right.
programmatically through the script.
So the script handles the creation of those resources for you, or you can also create those beforehand and then pass them on to as a parameter. So either way you prefer, you can do that. Okay. The script will handle both.
Okay, so as part of the first demo, we'll let the script handle everything. It will deploy this whole sort of the architecture that's displayed over here, right?
Yes.
Okay, so then ready to kick off the, what we'll do is we'll kick off the script and then jump back into Draw.io and talk through all the different resources and flows. Sounds good?
Sounds good.
All right, so let's deploy this to Azure. Again, this is with private networking. Okay, so we'll call this AI Foundry, and we'll call this private. And we'll put the link to the GitHub repo in the description. And that's about it, right? I can deploy it. I think there are a few important points to call out, which I will show you in the Draw.io as well, as the VNet name, the agent subnet name, and the PE subnet. And then these are the prefixes that we are using. And off we go. It creates a lot of resources that we will show you in the Draw.io. So we'll kick off this. It will take a few minutes to deploy. And just to recap, Gabe, this is the only way you could deploy a standard agent is through this script. We could not do it from the portal, right?
Correct. You'd need to use a Bicep template or a Terraform template to create this.
Okay.
To VNet inject these resources.
Perfect. So while we have this resources getting created, let's look at all the different resources that are going to get provisioned. Again, this is our starting point, just the Azure VNet on-prem and existing customer resources, existing customer PaaS services. And with this script, what the script will do is it will create this VNet, this blue box, and then a private endpoint subnet and an agent client subnet. It will also create all of these PaaS resources that are required for the AI agent service. So like Gabe mentioned, storage, search, and Cosmos. It will then VNet inject the agent into this subnet. Again, behind the scenes, it runs a container app, so it will VNet inject that. And it would also project the private endpoints for all of the actually, no, we're not projecting. The script is not projecting. It's projecting the private endpoint for this one. Yeah. So let me, I think this the order in which this my layer is off. So did I miss anything, Gabe, that the script would be creating?
Yep, you create those resources for the project capability host. You have the VNet injection for the account.
Yep. And DNS. All the DNS zones it creates, right?
Right. So it would create the private DNS zone so that the virtual network can properly resolve those FQDNs to its private IP.
So Blob, Cognitive Services, Document for Cosmos, OpenAI Search, and
services.
So it creates this, and script also creates the VNet link. So everything everything resolves properly.
Correct.
So for now, we'll just put all of these DNS zones that get created. So again, to recap, the script creates this PaaS resources required for AI agent service, the private endpoints, the private endpoint subnet, the agent subnet, VNet integration, and private DNS zones.
And just to go over a little bit
Yes.
more of
Yep.
how the standard agent creates the connection to those resources, there's something called a capability host. There's a capability host at the account level, and there's a capability host at the project level. The project capability host, if you were to look at any of the scripts we have, you'll see that it manages basically the project settings for that agent, meaning the connections to storage, to Foundry, to Cosmos would be handled by the project capability host, while the injection, the VNet injection, would be handled at an account level. So, for example, if I want to create a AI Foundry resource with 2 projects, I could have my account capability host with the VNet injection. And then for the projects, I'll have to set the project capability host. I have to create 2 of them, right? One for project 1, the other one for project 2. You can reuse those resources as long as the connection names are unique. And that way, both your projects would be VNet injected. So if I use the script, run it, it will create one project. I can't just create another project in the UI because it would not have those additional resources for the standard agent configured. So I would have to create another project programmatically as well.
Good point. Gabe just reminded me of something. Do you want to talk a little bit about the Class A versus Class B IP scheme that,
Absolutely.
yeah, because from what I know, I just lighted up the IP scheme layer. If you want to talk about what's supported today.
Yes, and that's a great call out, Nahali. I had forgotten to bring it up. So one very important call out as well for the agents. GA, we only support Class B and Class C subnets. So those would be of range 172.16, and then there is the 192 as well. IP range, Class B and Class C respectively. Class A support doesn't exist yet. It is something you can request on the GitHub link. We'll have more information, but it is a private preview. So GA availability for what we have is Class B and Class C subnet support. Okay. Does that make sense?
Yeah, perfect. Yeah, so for this particular one, we did choose a Class B 192, 168. And then as you can see, we sliced them into /24. So our private endpoint subnet, and then in the future, when I VNet inject the function app, I have reserved it, but basically the agent subnet is the first one, and then we have the private endpoint. Perfect. Let's see how our deployment is doing. Oops, it looks like it failed. Let's see, maybe I have something from before.
Can you click on that private endpoint? You might just need to recreate it. And bad request. Scroll down to, yeah. Can you click on the error details? And it's search Cosmos storage. It's just saying the VNet's not found. Okay. And can you go back? You might just need to rerun this. Doesn't look anything in particular. Do you mind going back one more? Let's just see if there are any other errors.
Back here.
To the previous deployment page.
Which one?
So just click back at the top of your browser.
Okay.
So yeah, it's just a private endpoint.
I haven't run into this before. Let's see.
Yeah, it's just complaining the VNet doesn't exist yet.
Which region did I pick? Is that
East
something?
US.
Yeah,
usually that has issues for like Cosmos DB.
Yes,
so
that's what I remember. First time I did it, I did it in the. So let me go ahead and delete this resource group. So, and then I'll do it in the. Good way to go again. All right, so we'll kick it off again. Let me grab the link to the GitHub repo. So we paused the video and we found that we need to recreate this to match the regions. So we're going to recreate this by putting both this region and align this region and this location here. That was what we found to be the issue. And AI Foundry, oops, private-rg. And is that good, or do we need to add anything else? Just a different resource group until the old one purges?
Yeah, that would be good. Yep, and the regions match now as well. The region and location
match. Yep.
Yeah.
Yep.
Okay. Perfect.
And just for the benefit of our viewers, we did have to go under AI Foundry, manage deleted resources, and purge the old Foundry private that we created. So that takes a little time. So we're going to put this in a different resource group in case that happens to our viewers. So we'll go ahead and hit create over here. And this is good real-time troubleshooting. Gabe, part of our sessions is we want to also incorporate some break fix in here. And so,
absolutely.
yeah, so while we wait, let's walk through the architecture. So once everything is deployed, the important thing to note about the private deployment is that we have no inbound to the PaaS services. So no inbound to the customer's PaaS services, no inbound to the mock API VM that we had, and no inbound to any of the PaaS services for the agent service. Okay, so that's inbound red now. And then what will happen is either this developer or this developer on-prem would access AI Foundry through either the private connectivity, in this case the VNET peering, but there is no access for this user to the AI Foundry. Okay, so no access for the external user. the way we would launch the AI Foundry is by logging into the VM and then launch Foundry. Okay. And again, the mock API, by the virtue of this VNET injection, the mock API is on a peered VNet, so it would hit it through this pink flow privately. And the same way, the agent will, I think I don't have a flow for agent to function app. Somehow I'm missing it, and I'm missing. So let me create that flow. Try to create it in real time. So the next flow is from this agent to this function. Oh, I know why why that flow is missing. So let's talk about that. So for this agent to talk to this function or to this AI search, we have to project the private endpoint, and we need to do this manually. The script will not do it. So we will project the private endpoints for all of the customers' paths into this private endpoint. And after we do that, our agent will be talking to the function through the private endpoint. And remember that anytime you want to use private endpoint with AI, with Azure PaaS services, be sure to check out that the SKU supports private endpoint. So that's the orange flow is agent to function. Remember, we have the function app running. And then this purple flow is agent to the search. So just to kind of cover all the different flows, mock API, function app, and AI search. Anything you want to call out about the flows?
Notice as well that for the agent to work, it needs that connectivity to the storage account Foundry or storage account search and Cosmos for that standard agent that we created, right? So even if from your VM or on-prem you have access to those resources, if for some reason, let's say your link was not created for the Azure Virtual Network, leading to DNS failures from that VNet, then you'd see issues in the portal with connection to agents, even though you yourself have access to those resources, the agent does not. So without that layer of communication,
Is
the
this
agent
the
won't
flow?
function.
Is this
Yes,
the flow you're talking about, Gabe? So
correct.
so from agent to all of these other services. That's the one I'm missing.
Correct.
I see. So let me just do this in real time. All right, so we'll just do it as the Cosmos and we'll color code it so that so this, and this will make it yeah, good call out. So we'll make it, I guess, let's make it orange. Okay, so yeah, so it's important that these private endpoints are in place.
Mm-hmm.
Okay, let's see how our deployment is doing. Okay, it's still working. Yeah, so what we can do is let's go to the next flow. So let's say that, let me hide all the other flows. Let's say that this function app needs to talk to this storage privately. What we need to do is we need to do a VNet injection first So we can VNet inject this function app into its own subnet. This will become more relevant. Walter has a more real world application where the function app talks to the storage. So we will go into more depth there as well. But just to kind of complete all the flows, once you VNet inject it, the function app will be able to talk to the storage. Okay, so that covers that flow. And then let's talk about the connected agent. So you could have in the same container app environment, you could have multiple agents, and they are all VNet injected. And when we have so many private endpoints, right? The script created the private DNS zones for this private endpoints. When you project these, the customer projects these private endpoints, be sure that the new zones are created and also linked, right? So for example, if you create a function app and you create this Azure websites.net, that you link this VNet. Okay. A lot of times we see DNS issues, very, very common. I've done a deep dive video on DNS from on-prem and how to set up hybrid DNS correctly. So be sure to check out the link below for hybrid DNS setup. Gabe, I'm sure you have dealt with a lot of DNS. Any advice on it? Any call outs that I missed?
I think, yeah, the VNet link is an important thing. Check what DNS servers your VNet is using as well. Sometimes the link missing could be for the DNS VNet and not the VNet that your agent is in, for example. There's so many things that could go wrong with DNS that it's hard to pinpoint just a couple. But I think it's always good to test from a VM inside that VNet if you have trying some NS lookups or anything like that to show you if the DNS resolution is working or not.
Yeah, great call out. Yeah, so typically I would, on a developer VM, if it's linked to the same private DNS zones, you will see that when you do the NS lookup, be sure that you could get the private IPs for any of the services, any of the Azure PaaS resources that you are using. And you could see that all of them resolve to private. And like Gabe said, there is a lot of moving parts with the DNS. There could be a VNet level DNS setting, and I've done a deep dive video on that when you're using Azure DNS versus your own private DNS server, right? A custom DNS server. So with that, let's take a quick look at our script. Looks like it's still progressing, which is great. So I'm going to show you, take you to this mock API here and show you how you can use a custom domain. Often in the real scenarios, we see that folks have a custom domain. Before we were using ngrok to have HTTPS and a certificate, but this time, just to keep it slightly different, to validate this flow. So for example, from agent to the mock API, instead of running it on port 8000 with ngrok, we will run it on port 443 with certificates. Okay, so let's, while we wait, let's get this mock API ready. Is that good, or are we still, did I miss anything in the architecture?
I think that we're good.
Okay, so let's go to this. We will get it ready so that it's listening on port 443 instead of, so we'll control C out of this, we'll clear this, and we'll control C out of this, and we'll clear this. We're not going to use ngrok. Before I was using ngrok so that we got HTTPS. Now let me get the right command here. So what we will do here is I have created I've used Let's Encrypt to create a few certificates. So if I do so we'll go to sudo -s. Let's go and see under let's see let's okay. So under app.nihaliniyogi.org, I have created the certificates. Okay, so we will be using these two certificates to launch our app. So kind of coming back over here, and to run the app on port 443, I have to be root. So as you can see, I'm using sudo and I'm listening on port 443 using the two certificates. Okay. So if your customer needs to use custom domains, be sure to, it's already in use. Oh, maybe I have Nginx or something running on this. Sudo, let's see, init.d. I may have something else running on it. So, all right, so let's start it again. Okay, so now it should listen on port 443. So great, we have the app listening on 443 using this certificate in this location. Okay, so let's validate it from outside and then we will configure it with when everything is deployed, we will use it with the agent in Foundry. Okay, so now that my app is running, we will, what we will do is we will jump on another VM and we will try to validate this. So coming back to the drawing board, my app is running here. We will jump on to this VM. So let me make sure that I still have access, my just-in-time access. So the first thing we will do is just to kind of orient ourselves. I'll just open up a PowerShell window. And I'll run ipconfig here. So we are on 172.16.1.5 and kind of jumping back over here. So we are on this VM and the mock API is running on 1.4. Okay, so this is my mock API. It's running on 1.4. Okay, so we'll try to hit this. First, we'll just make sure that our DNS is working correctly. So let's jump back over here and I will look up ns lookup app.nihaliniyogi.org. So I've created a private DNS zone for it, and you can see that it is indeed resolving to the private IP. I will show you the DNS zone for that next. So there, if the customer brings in custom domain, it does require a few more steps. So I want to kind of ensure that this is something we often get escalations for. So I want to make sure we show you this part. So if we go in here, I have created a private DNS zone called nihaliniyogi.org. So from inside the network, by the virtue of these VNET link, I will get a private IP. So here, and if you look at the record set, I'm pointing my app to 1.4. Okay, So now if we jump back on the VM and we can test if our API is working properly with the new certificate. And if you remember our test from before, when we were running it on port 8000, we were passing a subscription ID and we were getting a list of VNets. That's what the API does. So we will do this and let's see what it does. Now, if it doesn't work, we will have to check the port on the VM, whether it's allowed. So while we wait, it looks like it is not working. So these are some of the things, I think Gabe mentioned this before as well, that all of the firewall rules and everything have to be open on that VM. So let's ensure that, yeah, so 443 is indeed blocked over here because of the rule. So for now, we will remove this deny rule and make sure that 443 is allowed. We'll refresh it. So now 443 is allowed. So now let's try to hit it again. Oh, there we go. It is listing the VNets, and let's validate the certificate. So we can look at the certificate and you could see that the common name is app.nihaliniyogi, and I have created the free 3-month Let's Encrypt certificate, right? I'm sure your customers will bring a valid certificate, but this does work with AI Foundry, so it's quite useful for labbing purposes, and AI Foundry will not work until you have a valid certificate. So now we are ready. Our app is ready for integration. Let's see how our script is doing. Oops, I lost track of where I was deploying now. We were oh, there. It's still deploying. Okay, so no issues there. We could do a couple of other troubleshooting as well. I just wanted to record some of these commands that can be useful. So if you can just, if you do have custom domain, you can also look at the show certificate and it will just validate that your certificate is set up correctly. And that's it. We'll pause the video until the script is deployed. So we paused the video there, and now our deployment is indeed complete. So what we'll do is we'll validate the different resources in this deployment to match what we showed you in the architecture diagram, all the different private endpoints, the DNS zone. So Gabe, I'll let me put you in the resource group where we deployed all of these resources, and then you can walk us through the different resources, and then we'll try to launch AI Foundry after.
Okay, let's do it. Okay. All right, do you want me to start from here, the resource group, go over what was deployed, and then, yeah, I think that would be good, right? Let's just go over all the deployments that it made. We don't need to go individually one by one, but like just kind of have a general overview of what was created with the template, and then we'll go into Foundry.
Sure, yeah. So looks like we got AI Foundry, DNS zones, and let's maybe take a quick peek at the VNet, show the VNet delegation over here, right? So the agent subnet and the private agent endpoints subnet,
Yep.
and then the delegation here, and then you want to launch AI Foundry. We expect this to fail because
We're outside, yeah.
yes, if we go to the networking tab, public network access is disabled. there is indeed a private endpoint, and then there is indeed VNET injection. If I hover over it, as you can see, it's injected in the agent subnet. So if we go and we try to launch it, it will fail. It works up until here, but if we go and try to do anything, it will fail. So if you get this message, that means that you have public network access disabled and you're trying to access it from public. So we'll do the exact same thing, but this time we will do it from the VM. Is that where you wanted to be, or did you want to show any other resources, Gabe?
Let's go back to the resource group. We can just walk through a little bit of what
Okay.
was created.
Sure.
So yeah, so here, if you scroll all the way up, we'll see that one, obviously the Foundry resource was created, and notice there's also a Foundry project created. The project is what you'd mainly be working on, right? See here, we also have the Cosmos DB account that was created, right? And together with that, we have a bunch of NICs, private DNS zones, private endpoints that were all created for this private scenario. So if you look at the private endpoints, there are 4 private endpoints. If you scroll a little bit down. Okay, so if you look, the first one should be the AI services one, which is the AI Foundry resource. The second one would be the Cosmos, third one search, fourth one storage. If you look at the number of private DNS zones created, there are 6 instead of 4 because the Foundry one creates 3 private DNS zones, one for the AI services endpoint, one for the OpenAI endpoint, and then another one for the cognitive services endpoint. For storage, search, and Cosmos, you'll see one for each. Storage, we are only using the blob endpoint, so we only need to create blob. For Cosmos, we use documents.azure, and search, we use search.windows.net. Okay. The network interfaces, if you're familiar with private endpoints, you see those created as well for any private endpoint you create. At the bottom, you also see the search service resource created and the storage account created. Okay. And last but not least, the virtual network that was created for this deployment. So if we click on this VNet, and navigate to the subnets, we will see there are 2 subnets. One is the P subnet. The P subnet is going to contain all those private endpoints that you saw previously. And then you have your agent subnet. Note that it is delegated to Microsoft.app/environments. Without this, you would not be able to do the VNet injection for these agents, okay? So if you're using bring your own VNet and it's failing, you're not sure why, validate that you do have that delegation set, okay? Yeah, that should be it. That should be it here. Those private DNS zones should also all be linked to the agent VNet test that we just created. So if we click on one of them, we should be able to go to virtual network links. And so this means that this virtual network, since it's using default DNS, it's going to use the ARR, and then it's linked to this private DNS zone. So when it calls the storage account of QDN, it would resolve to its private IP that you would see in the record sets here. But yeah, that should be it. That's what we create. So we can go back to the AI Foundry.
Awesome. Yeah, so that was a great kind of overview of all of the different resources. And just to kind of highlight, these are the four private endpoints, 1, 2, 3, and 4. Okay, and then we have also listed the 6 DNS zones that were created. So now we are sitting on this. Let's walk through the flow one more time. So now we are accessing Foundry from this developer VM. By the virtue of this VNet peering, we should be able to access it. So I just want to make sure that this peering between my subnet and this is intact, because otherwise this will fail as well. So, which it is not, so I expect even internally to fail. So this is the private one that got created, Gabe, right?
That is correct. It's going to use AI services plus like 4 random generated letters, numbers. That's why you see that SM.
I see. Okay. So public disabled, private enabled, VNet injected, but I believe that I still have to create a peering, so I expect this to fail as well.
Okay.
So, but we will just do that. So it's a good error to see. Yes. So what has happened is I am on this VM, and I haven't created this VNet peering. So if let's test one NS lookup before and after, because this is a good troubleshooting trick. So what we'll do is we'll try to NS lookup Foundry here, and let's see what we get. So we'll be here, and we'll try to keys an endpoint, and we try to NS lookup this one. We should get a private IP. This is because, now going back to the drawing board, I haven't created VNet links to all of these private DNS zones. So I need to create these links as well to these private DNS zones. All right, so let's go back, and it's going to be, we have 6 of them. So let's go back and create them. So all the new ones that got created, so let's filter it by resource group. So Gabe mentioned 6 DNS zones. So what hasn't been done, and the reason why it's not resolving properly, is we need to create a VNet link. So link to my, we'll call it link to VM subnet. VM,
right?
VNet, yeah, good call out, yeah. So that is hub VNet East.
Nice.
Create, and we'll just quickly kind of run through this.
Net.
Thank you, Gabe, for keeping me honest here. I'll just quickly run through this one by one. And So this is good because we can now see the before and after picture. And let's wait it. We may have to do flush DNS. Let's just try that. There we go. We get the private IP. And same should be true for the rest of the private DNS zones. And everything should now be private. Let's go back, jump on this here. I have to move this a little bit on the side. The Teams is getting in the way. All right. You guys can still see my screen okay, right? Okay, so now let's refresh this to see if this goes away. Should we check?
Yeah, you can do Control-Shift-I and C. Sometimes this will be cached as well, so you might have to do a cognito session.
Sure, yeah.
If you refresh this page, we can see as well. Okay. See the calls to assistants on the left side. Yeah. Yeah, it's just not resolving to anything, not getting anything back. So I would do an incognito session and just try that.
Sure, and then we can check just real quick that one, right? Okay, so that is indeed resolving, but maybe the browser needs a refresh, so we'll just do a new incognito session. It's still going.
Is the peering set up correctly then?
Let's double check the peering to make sure that we peered to the right VNet. So if we go to the hub and take a look at this one, yeah, looks like we peered to the wrong VNet. Let's remove this one and add it to the right one. Yeah, so a lot of things can go wrong. In a way, this is good. I think we've done something similar before, right? Where we do a break fix, intentionally break and fix. This was good that we got to see this in action. So this is peering to agent VNet, and we'll pick the right one this time. We ended up having two because the first attempt failed, right? So we'll just say peering to agent VNet on this side. We will say peering to dev VNet. So we're starting from the hub side, we're peering to the agent side, and then we're doing the opposite, right? Let's see. I also want to make sure that we don't while that's happening, we don't keep that other resource group hanging around. Let's just make sure that that one's completely deleted. This is the old one. Yeah, it still has this not deleted for some reason. Maybe it's the delegation. So we'll leave this for now, but I think we have to be mindful about not using the old resource group. But sorry, I'm jumping around a little bit here, but just to kind of come back, let's go to the hub VNet again here. Looks like our peering is done. Let's give it a go again here.
Yes.
Yeah. Yes. That was a good call out, Gabe. Thank you. So that tells us that we now can launch the Foundry properly. And is there anything else you want to look at anywhere before we start this?
Absolutely. So if we look at the agent first, right? On the right side, notice the difference. You see here at the top that there is a AI search connection and a Cosmos connection here. This was because of the capability host we set up on the script to use these your own resources, right? If you look at the public one, this is not set because it is a basic agent, okay? If you go to the management center, we should also see the connection here. So go to connected resources, and now you see there are 3
Nice. Yeah.
connections, one for the Cosmos, one for the AI search, and one for the storage account. Okay. Yeah, those would be like the main differences you'd first call out. You may see as well when you create the agent, we showed here an error when your machine doesn't have access to Foundry. If we were to remove a VNet link for the agent VNet to, let's say, the Cosmos private DNS zone, you would also see similar issues in the agent portal regarding connectivity, but it would not mention access to Foundry resource, right? In that scenario, the problem would be that the agent subnet cannot access the Cosmos resource. So just make sure if you're getting some errors in the UI, 1, check your connectivity, 2, Foundry, to check the agent VNet, specifically subnet connectivity to those resources, okay?
Yeah, that's a good call out. So it's this flow you were talking about, Gabe. From the agent, these private endpoints.
Correct.
So not only the DNS links here, but also the routing, right? Like it
Right.
needs to be connected. Yeah, good point. Yeah, so let's go back in the portal here. Anything else? Let's go back to the project. Should we?
If you go to models, there should be one created already.
Okay, nice.
Yeah, you'll see the GPT-4o. We created that with the template. If you go to agents as well, every agent you create follows the same capability host configurations for the project. So if you create another agent here, you will see those same search and Cosmos connections added.
This one. Yeah, that's a good point. I Can't remember taking a close look at the other one. Let's just for completeness. So what you're saying is in this agent here, this was the public one which we already did. I see. We don't see those search and the other connections, right?
Correct. Yeah.
I see.
So
Perfect.
if you see that and you're trying a private scenario, it won't work. Please make sure that you create using some of our templates so that you use a standard agent setup and not the basic agent. Okay.
Yep, makes sense. So should we now create the same, quickly go through the same network assistant agent, but except this time we will hit it all using private endpoints?
Absolutely. Let's do it.
Okay, almost there. Okay, so network assistant 2.0 private. And let me grab the instructions from here. We'll just use the exact same instructions. And so far, the only integration point that we have ready to go is the open API connection to that VM, right? And the mock API.
Right.
We still haven't projected the private endpoints for these customers. So we still need to project these endpoints, right?
Mm-hmm.
So we can maybe start with the mock API flow. This flow will work. We can start with that and then we will add this private endpoints. Or should we complete all the private endpoints and then look at the flows?
Let's complete the private endpoints. Then we can look
Yeah,
at the.
that way we have the full. Okay, so we have to do it for search and for function app. So let's complete the search, and then we will look for function app. Okay, so I already have an AI search private. Let's just let's disable it first from all networks. Do we need this checked, Gabe?
Yep, I would check the allow trusted services.
Yeah. So we disable it from public and then we create a private endpoint. Let's look at the function app while it's saving. The function app. So function app, yeah, we have it enabled because we were testing public. Let's disable this. Did you want to check this? Does this also have Azure services or no?
Not sure. I don't think
Okay, let's
so.
try.
But not as familiar with the function app
Function
setup.
app, yeah. So we'll just disable it.
Yeah.
Okay, good. And let's see how, while that's disabling, I know this one does take time. So we'll do this.
Should be able to add the private
Yeah,
endpoints now,
yeah,
right?
yeah. This the function is done. I think the other one isn't done yet.
Okay.
This one
Yeah.
takes, I know the search takes time. Okay, so let's go ahead and create the private endpoint for the function. So add advanced. It's going to go into that agent VNET. And we just have to be picking the right VNet in this RG, and then we'll use the private endpoint. Subnet, DNS. It's going to create a new
private DNS zone.
Yeah, it's going to create a new private DNS zone. Just want to make sure that yeah, so that would be okay. I have another one, but this one's going to be linked to this VNet.
Yeah, it would link it to the agent VNet since it's a newly created zone. If you're adding to any existing zones, just make sure that to double check the VNet link is there.
Yep.
Otherwise, that won't do it automatically.
Yep. So we will go to the create here. Let's see. This search is still updating. Okay, so those were the only two private endpoints that we have to project. So coming back to the drawing board, we just projected the function app, and we need to do this one.
Awesome.
Let's go back. I know this one does the search one. I know it takes time. So what we can do is we can, while the search one is, we can let's pause the video here.
Okay.
So it looks like, Gabe, this one's still going. So in the interest of time, let's start with the function and our mock API, and then if we have time, we'll revisit search. How's that?
Sounds good with me.
Okay, so we have, let's go to the function again and make sure that we have the private endpoint. So we'll go to the function app, demo function app, networking, and oh, there is the private endpoint and no public access. Okay, so let's just quickly take a look at the function app, and I just want to make sure our function app resolves to the private IP first from the developer VM, and then likewise it is not. I think it could be related to the fact that we have I have two Azure website private DNS zones.
So I think the problem
Yeah,
might be because we created that private endpoint and we created a new private DNS zone and we linked it to the agent VNet. So if you're doing an NS lookup from your VM, which is in a peered network, that VNet link is not going to be there.
yeah. So let's fix that. How about we navigate it from this side? And we had the Azure websites. So I have two. So this is the one of interest. And that one, as you rightly pointed out, may not have a link to our VNet. Indeed, to dev VNet. So that's the right one. And now if we go here, we should see, oh, just wait, it's not created yet. So it looks like this is still not resolving. I think I already have a I have two Azure websites, so let me clean up this previous one first so that we can link it to the right private DNS zone. So this is my developers VNet already linked to another one, and you cannot have two. So we'll delete this one. And we will link it to the Azure websites.net that is in the AI Foundry resource group. Okay, so let's let this finish. And here we only have the link to the agent VNet. We will add the link to the developer VNet. And now our NS lookup should work. Okay, there we go. Private. All right, so let's get our agent to kind of going back to the drawing board. We will now work with the agent talking to the mock API and then agent talking to the function app. Okay, so the pink flow and the orange flow. So let's start with the mock API. And what I'm going to do, Gabe, just to kind of copy it off of right here. So this is the public one that we've already done. So let me move this to a different window and we can copy. So we will do an, we'll start with the action, open API 3.0. We call it mock API lists. And remember earlier, I showed you that now we're no longer using the free ngrok one, but we are using more of a custom domain. So we should change this to app.nihaliniyogi.org, right? And rest of it should all stay the same. And we also need to fix the instructions for the agent. So let's fix this, copy paste the instructions from the public agent that we had. Oh, looks like I already had it. I'll just copy paste the instructions again. Looks like I already had it, but I accidentally deleted it. Okay, so we'll put the instructions here. Okay, so we have instructions. We have one action with mock API, and then let's add, let's test this first. So try and playground. So list VNets in subscription 1, 2, 3. It's calling Open API. Awesome. And we should see that reflected also on our console. So let's take a look at this one as well. So I'm gonna so this is our API. Let's try to hit it again through the private connection. Actually, let's look at the run info just to be sure. And it's calling, yeah, the mock API. And if we look up app, I just want to make sure Nihali Niyogi dot. I feel like it's hitting the external. So app.nihaliniyogi.org, and it's private. Let's just make sure that we are using the action. The reason I thought it was using, because I expected the IP, the source IP, to be some sort of private IP. So list VNets in sub 1, 2, 3, 4. It doesn't like the list VNets in subscription XYZ. For some reason, it didn't like that. But I think the important thing from the network perspective is if we look over here, I expected this to be a private IP. So Gabe, something isn't quite right because I expected that call to come from the agent VNet. You know what? I think our that nihaliniyogi.org isn't linked. So going back to the whiteboard, this agent is still resolving public. This is a good exercise. So we need to create this link to nihaliniyogi.org. So for this flow, it will go to the private IP of the VM.
Yes.
Okay, so let's go and fix that. So nihaliniyogi.org isn't linked to the agent subnet. So agent VNet link. So even though the dev VM was resolving it, the agent VM was still not resolving correctly. Agent subnet or VNet that's in there. Okay, so if we create this, yeah, so this is more real world like, so I incorporated this custom DNS zone, and I'm glad that we saw this issue. So let's, once this is integrated, I expect that on this mock API, we should get the source IP as something from this subnet. So kind of going, if I light up the IP scheme, it should be something from the 192.168.0 network when it hits this mock API. So let's see if this one finished. Okay, awesome. And let's give it a go. List VNets in sub ABC. It's calling Open API. All right. Now let's go look at the aha 192.168.0.
Perfect.
That's the VNet injected agent, right?
Correct. Good catch, Nolly.
Yeah, thanks. So now we go and we test the function. So let's go back to the portal. So let's go back to the VM. Let's make sure, I think we checked this, but let's just make sure that the function is Yeah, we did test the private endpoint for the function, right? So am I in the VM? I think I lost my PowerShell somewhere. I think I lost my PowerShell somewhere, so let's just do this again. So at least my VM is resolving correctly, and if we can just verify that we did verify that
Right. Yeah, we created the private endpoint on that agent VNet, so the link should be there.
Link should be there. All right, so let's create the action. Here we'll create the action, and what did we call this action? So we have two actions there. We have a ping action. So I think if I do it from here, it works. If I have to add a new, so we'll call the ping action. We'll say, we'll enter a description. We'll click next. We'll enter the OpenAPI spec here. And we'll create the tool. And we'll add another action as well while we are here. So we'll add the HTTP header. I'm just copying from the public one that we already created. So everything stays the same. The beauty of this is that the FQDN for the function stays the same, right? It just resolves to a private IP now.
Using the same function.
What's that? Yes, we're using the same function app. Yeah, we just disabled the you just
public
disable
access.
the public access. Yeah, so that's how private endpoint works. Like if you're inside, it would keep the same FQDN, and we don't have to change that.
Nice.
So, all right, so ready. So let's, so now that we've added this, let's try it in Playground. And we say ping. Looking up, and we got Pong. We can look at the thread logs, and it called the ping action. Open API. And if we say list HTTP headers for the API call, this gets interesting with private endpoints, right? We did this in, so let's see what it sees. It's indeed calling it. And here my eyes land on the X forwarded for header, which is this one showing us that indeed it's the agent in the 192.168.0 talking to the function app. So kind of going back, it's this flow. And in the X forwarded for, you see the source IP as the IP of the agent. Do you see anything else interesting in here? I don't know. I think this is abstracted from us, but this must be somewhere within our Azure infrastructure that's hosting the agent. Oh, I can also see the user agent here as Azure agents.
And the host it's calling is the correct host as well.
Yeah.
Which is the function app.
Yeah, awesome.
Yeah, looks good.
Looks excellent. So should we just do just from a private networking standpoint, let's add the connected agent. So I'll just copy the connected agent from our public demo. So we'll do new agent. We'll call it check health. We'll copy the instructions. These instructions are important. And then in the connected agent, we'll add our other agent that we created, the network assistant. We'll call it network assistant connection. And we will give it a description. And off we go. So let's test it in the playground. And this one, if you look at the description, what it will do is if we say health check, it would call the connected agent and run all the commands for us, ping, headers, and list VNets and subscription. It's calling the connected agents.
Nice.
Well, I think it did the headers we didn't get. We got ping pong, we got the VNets, but we didn't get the headers. I'm wondering if it says HTTP headers, if we say, because the same thing worked in the, we can give it a go one more time. Call it system check. So it didn't call the middle, this one. I expected
middle function.
Yeah, I think it may also have to, now that I think about it, it may also have to do with, yeah, I think the way it formulates the JSON for that one, because we had a lot of content. So now that I think about it, I may have an updated version. Oh, no, we got it. Yep. So perfect. So I do have that here. See, it says headers ... So for some reason, I had to add HTTP over here. So what did I say? Health check. Let's just do a health check. Okay, so now it's all working. I think this was really all working with private networking, right? So we just had this call right here, and we had this call right here. So Gabe, one more flow, hopefully the last one that we should talk about is outbound from this agent to the internet. So if there is a firewall or an NVA in the mix, the the default route, if it's pointing to the Azure Firewall subnet, the flow would look something like this. So so two questions. One is it possible to not have this firewall at all and have it follow the default outbound and it would just work? That's how we're doing it. We did everything
Right.
today, right?
Right. So yeah, you can absolutely not have any firewalls there. That's what we showed today. But in the scenario that you do have a firewall, you might need to open a couple outbound rules as well.
Got it. And you want to go over some of the rules here? I think I have the,
Yeah.
yeah. So let me just
this
show
is
the top of the document. So yeah, go ahead. Go ahead, Gabe.
So this is from the Azure Container Apps documentation, right? Which is what the agent's underlying containers are using. So if you see and scroll down here, if you have outbound traffic going to Azure Firewall, list a few of these required rules here and their scenarios. For the agent scenario, we need one, the mcr.microsoft.com, right, which is covered in all scenarios. So if you look at the application role, this would apply also to like third-party firewalls. So if you have a Palo Alto firewall, we want to add the application roles. If you have an Azure firewall, you can look at the scenario and say, okay, is the scenario covered by a network rule? I can add a network rule. Otherwise, I add an application rule. Okay, so from testing, what we see is that the one needed in all scenarios, which is to the Microsoft Container Registry. Those rules are needed. And also, if you see the scenario for Spire dashboard, which is going to be region.ext.azurecontainerapps.dev, that would also be required. So if you're running into issues with agent connectivity, check your firewall, see if these ports are allowed or these hosts are allowed. Okay. You may also see calls from the agent subnet to login.microsoftonline.com, for example, right? Just make sure that if you see that being blocked, you're cross-check with the table and make sure it's allowed from your agent subnet.
So then would this login.microsoft online, if it was an Azure firewall, would be covered by one of our service tags, right?
Correct. So you could add a AAD network role, so Azure Active Directory service tag, allowing that traffic to be reached from your agent subnet, and that would cover it.
Got it. Great. Thanks for covering that, Gabe. I think that was an important flow outbound because the rest of it were all sort of going within the VNET, and this is actually going out to the internet. So that's the green flow. Perfect. And this could very well be an NVA. Of course, there has to be a default route, quad zero route on this subnet pointing to the firewall or the NVA. All right. So perfect. Thanks, Gabe.
Thank you, Nahali.
Okay. So our connected agents worked well. And just for completeness, Gabe, I'm going to just show that the network assistance, we did it in public as well, but if you ask any other questions, so what is the capital of Texas? It should not give us that information because it says, oh, buddy, I don't do geography. We told it to be funny. So our Boston style, since that's my turf. So it's doing the right thing. I think we tested everything. So Gabe, that brings us towards the part of the demo where in this scenario we used your script, the script to deploy everything. in a new VNet, but we want to use the BYO VNet demo as well, because that's even more realistic, more our customers would be looking for something like that. So is that something you're ready to demo? Should I turn it?
Sure.
Be
Let
ready for
me
that?
share my screen.
Okay, I get to sit back and relax now.
That's awesome. Are you able to see?
Let me just one sec. Okay, but it's on my, yeah. Let me see the font. Just, yeah, that looks great.
Awesome. Okay, so I'm just going to create a new resource group and begin this deployment. So this is running while while we go over it, the modifications we need to make. Okay.
So Gabe, this is from that same GitHub repo. Do you want to put that one up where this
That is correct. So this would be from
the same repo we looked at earlier, right?
Yeah, so this is from the same repo. Instead of just clicking deploy, I'm using the actual
So you git
bicep
cloned this one.
files.
Okay,
Yeah,
so you
so you
git
can clone
cloned
this
it.
repository and then
Okay.
follow the instructions to run, right? We do cover our prerequisites and what's needed, making sure you register all these providers, and we'll cover the subnet delegation here as well. But what you need to be able to deploy this is all mentioned here, okay? And it goes into details of the bicep param file. So to begin, here we have location. This is where your resources are going to be deployed, okay? So in my scenario, I have my virtual network in West US, so I am setting the location to West US, okay? Here services, that's just the name, model names, the model deployed with it. This is all fine. Here we can modify the project name. We can name it anything you want. This is just going to be named project, the description for it, and its display name. Now, if we're going to talk about the virtual network, these are the parameters that are going to be the most relevant. So for example, here, the existing VNet resource ID is going to be the full resource ID of the virtual network you want to use. So in my scenario, this is the VNet, right? So if I go to properties, I should be able to see my resource ID here. So in this case, I just update the resource ID to use that VNet. I then use, this is the VNet name, need to add. This is the agent subnet name. So if you see here, I have a few agent subnets. This is agent subnet 3, since this is a new deployment. Each subnet that you have agents in needs to be delegated, okay? Otherwise, this deployment will fail, okay? So here I created agent 3 subnet. That's what I passed as the agent subnet. And you'll notice that for the PE subnet, I just use this default subnet. That is where I host my private endpoints. So that's where this will be located, okay? Now, one thing that is important is in this scenario, this VNet that I have already has private DNS zones, okay? So for us to properly deploy this template, we have to make sure that we're passing the resource group of these private DNS zones here, okay? Because if you don't pass this resource group, it will try to create a new private DNS zone and link this virtual network to the newly created private DNS zones. And since I already have these links created, it will fail, okay? So if hypothetically I only had the links for my AI Foundry resource, so these private DNS zones over here, these 3, but I did not have Surge, Blob, or for Cosmos, I could leave these empty, right? Leave this empty and run it like this. It would then not create these zones, but it would create the bottom zones and link them, okay? And for what I'm doing here, for what I'm doing, I have all these zones. So that's how it will work. And then everything else, these parameters will not be used. So they will be ignored. And yeah, it's as simple as that. Just clone it, change a few things, make sure that you have the prerequisites met, and then it will create this for you. So if I go to resource groups, I should be able to see my, where is Foundry IO? And now these resources are going to start getting created. Okay. So anything I may have missed, Nahali?
Yeah, so two things, Gabe. I noted, what are the three at the bottom, the params at the bottom? Are they at play at all?
Not in this case because I'm passing my own virtual network. If I am not passing the virtual network, these are the ranges for
It will
the,
use. Oh, okay. When I did
yeah,
it. Okay.
correct. Yeah.
And the second question was, I noticed your VNet was can you go back to your VNet? I noticed that it
Absolutely.
was a 10 dot network, but was it a slash
It
uh,
was, so
a
it is a Class
class?
A subnet.
Uh-huh.
So now how this works is I have allow listed for the private preview. So that's why I'm
Mm,
deploying it like this. Otherwise, if you are not, you'll run into issues deployment, the deployment will fail. So you'd have to, and notice as well that there is limited support for those regions. So to begin with, right, so you should use Class B and Class C.
I see.
Those are
So
the GA.
G8.
Yes, and in our official documentation, you will also see the same. So
Do we
if I
call
bring
that
this
out?
up,
Yeah. Yeah.
so we mentioned that Class B and Class C are the only ones that are supported at this time. Okay.
But if a customer did need, for whatever reason, the whitelisting that you showed, is that something through a support case, or
Nope.
we don't
Do not
honor that?
do
Okay.
not open any support cases for this. This
Okay.
is not something that support can help you with. It would be outside of support scope. So just make sure
Okay.
that if you do want that Class A
Mm-hmm.
on the GitHub, you can contact um, PG directly if that is something, and then
I
they'll
see.
analyze and see if that's something they can work
Okay.
with you.
And in
Okay.
your case, the reason it worked is because it was um, whitelisted, so to speak, or the term, what's the
Yes.
right term?
Yeah.
Yeah.
My subscription is like allow listed for, or
Yeah.
whitelisted, allow
Listed.
listed
Okay. Okay.
for this, right? So that's it. It will take a little bit. You see it's going through. The private DNS zone or the private endpoints are being created, right? It's creating these zone groups, so it's all good. Since I already have those private DNS zones, they are not going to create it in this resource group. So I have another one with all of the private DNS zones. Yeah, so here I have a lot of private DNS zones already. So services.ai, search, OpenAI, blob, cognitive services, and documents, right? So I passed all of these. I passed the resource group that they are in. And so if we look at Cosmos, for example, the virtual network link already exists for my AML VNet, right? So, and for customers that already have this set up, make sure you use the script that can update the to pass existing private DNS zones. Otherwise, you face issues with the
Yes, I
creation.
can already see with so many DNS zones that if it's
Mm-hmm.
not set up correctly, the DNS might be the issue that we would see. So going back to how you kicked off, I think I must have blinked. Can you go back into, so the way you, so the you git cloned the repo, you created the resource group, and you just modified your params file with your, and then you just, so there's really two commands other than, of course, all the prerequisites.
Yep, that should be, yeah. I basically just created a resource group and then ran the deployment with a simple deployment group create, which is gonna create this.
I haven't yet
right?
tried this myself. You've inspired me to try this because it's something we usually get as an existing VNet or a BYO VNet scenario. So this is really good to know.
Yeah, so I can also, while we're here and that's deploying, we can talk about, right, this is the project capability host that I was talking about earlier. Here you can see the vector, the storage, and the thread storage connection, right? So search, storage, Cosmos. These are basically what defines the standard agent, and these are the properties that you'd see, the Cosmos DB, Azure Search, and AI Search that were created. And the one I just deployed, I'm also not passing these resources. If I added it here, obviously, it wouldn't create it for me. But since I didn't, it will still create a new one, which should already have happened, right? So the private endpoints are getting created, and you can see a new Cosmos is being created. But notice we don't have the virtual network here, the private DNS zones here, because those already existed.
Yeah, the BYO. Yeah, makes sense.
So
yeah, this is awesome. No, this is a great demo.
And anything else, Nalia, you want to cover on this?
So Gabe, I think just to kind of recap this whole session that we did in the terminology. So there is public, there is private, there is basic, and then there is standard. So maybe just kind of summarize those terms for us. That would be great.
So yeah, basically a standard agent is, where is it? Standard agent, right? Standard agent is independent from it, the networking portion, right? The standard agent, it tells you if you want to bring your own resources or not, okay? So I can have a public Foundry where I bring with a standard agent. So basically, I'm bringing my own resources still, while Foundry is public and those resources are public, right? Usually, you probably won't see that, but that is a scenario that can happen. If you have a private scenario for AI Foundry, you would have to use a standard agent because the VNet injection, right? VNet injection needs to happen, which needs to happen programmatically with the definition of the account capability host, and we need to use a standard agent because that would be the only way we can access those resources privately. Okay, does that answer your question?
Yeah, perfect. Yeah, it does. So one question, in the event that some customer want to use public networking, but BY bring their own resources, so storage, search, and what was the third
Cosmos.
one? Cosmos, yeah. If they want to bring their own resources with public, is that possible?
Yes, that would be possible. You'd have to do it programmatically, but yeah, it is also possible.
Yeah,
I can
perfect.
link the documentation as well for the standard agent if they want to bring those own resources. Cool. We can see also deployment. It's now on the capability host creation, so we should all be almost done with this. Okay, and then we can pause and wait for this to finish. And all right, so we paused the video for a second to just show, just while this was finishing, you can see that the resource was provisioned. You can see it outputs all of the information for it here. If we go back to the resource group, it ran through all of the deployments are completed. You can see that, again, it created those AI services, Cosmos, Search, Storage, the private endpoints for them, but note there's no virtual network here. There's no private DNS zones here because they were already created. So, yep, we won't go into the connectivity here. We already showed that previously with the greenfield, but yeah, that's it. Holly, any other notes on this?
No, this was awesome. Thank you for showing this, Gabe. Um, so yeah, I think this was our last demo. Thank you again, Gabe, Walter, and also Meera joined us at the beginning for your collaboration. Thank you everyone for joining us. Hope you enjoyed the video. In the next video, we will look at a more realistic scenario from a developer's perspective. Walter has a great workshop and a demo prepared with private networking and a developer's perspective. If there's anything else you would like to see in these videos, leave us a comment, let us know, and we'll consider it for our future videos. Thank you again, everyone, for joining. Have a great day.